In section 7.5, we're factoring second degree polynomials, which are going to be set up in this type of format where we have our variable squared. We may have an x to the first term and then a constant just number term. We refer to a, b, and c as the numbers involved in this equation. But before we get into factoring, let's revisit what we know about simplifying or multiplying binomials. So you either use the FOIL method or the box method to multiply these two binomials, making sure that we can multiply each term in the first binomial by both terms in the second binomial. So I use the box method most of the time. So I'd put x and 3 on one side and x and -7 on the other, and then multiply in. So x times x, that's two x's multiplied together, so x to the second. X times 3, that's 3x. X times -7, -7x, and then 3 times -7 is -21. So then writing our answer here as a polynomial, I'd have x squared plus 3x minus 7x minus 21, pulling all of those numbers out of the box. And also notice that we have our two um, uh, middle terms here that are like terms, so they're both x to the first power, so we can add those together as we combine like terms, and we'd end up with x squared 3 minus 7, that's negative 4x minus 21. So there's our uh, result of multiplying these two binomials. So what we're doing in section 7.5 here is we're going to be starting with a trinomial like that, and we're our goal is to start at this trinomial, and we're going to work back to a factored form of two binomials. So I want you to notice that um, if I'm looking at this trinomial, the -21 comes from multiplying the 3 and the -7. So we're going to be looking for two numbers which multiply to c. So that last term. But the hard part is there might be lots of different combinations of numbers that multiply to that final term. So we need to figure out how do we take this middle term and split it up into two separate numbers that are going to add to this middle term. So we need to find two numbers who multiply to c. Well, a times c normally, but in this case, a is going to be 1, and who also add to b to that middle term. So the way that I'll encourage my students to do that is to set up this x just to help us do this more visually. We'll look at a times c. In this section, a is always going to be 1. So we're going to put c in the top section and our b value, whatever that is, in the bottom section. And then we'll look for two numbers which multiply to the top of the x and add to the bottom of the x. Then in doing that, so thinking about this one up here, if I had -21 in the top part of my x, my c value, and -4 in the bottom part of my x, then I'd be thinking, okay, what are my numbers that multiply to -21? So I could have or I could have 1 times -21, or 21 times -1, or 3 times -7, or 7 times -3. So here's my pairs of numbers, and I want to decide which ones could add to -4. So there's no way that 1 and -21 or 21 and -1 could ever add to 4. They're 20 units apart. but 3 plus negative 7 adds to negative 4. So those are my two numbers here. And what I've figured out then is how do I split up that middle term, or what are these two boxes right there? Then um, if I were working backwards all the way through the box, I could figure out that I need x times x on the corners to make x squared, x times 3 to make 3x, and x times negative 7 to make negative 7x, and then there's my factors on the outside. So when I find these two numbers, when a is 1, then I've got my two factors for my binomial. So let's look at a few examples. So in number 1, I have a, b, and c there. So I'm going to start with my x. And on the top of the x, I need a times c, so 1 times 7. And on the bottom, I need b, so 8. So now I'm looking for what numbers multiply to 7. So that's 1 times 7. There's no other numbers because 7 is prime. So 1 times 7 makes 7. Is 1 plus 7 8? Yes, it is. So there's my two numbers. I need to split up this middle 8 into 1x and 7x. So I'd have c squared and 7 in the top left and bottom right corners. And I can split up my 8c into these two boxes as 1c and 7c. That's what these are giving me. So to make c to the second, I would need c times c. C times 1 would make 1c. C times 7 would make 7c. And here's my two factors, c plus 1, c times 7. Now I'm factored. So anytime a is 1, we don't really need to use the box to go from our x to our factored form. I've figured out my two factors already. So moving along to number 2, a, b, and c. The top of the x is going to be c, so 64. The bottom of the x is going to be 16. This one's a little tougher because a bunch of numbers multiply to 64. So what multiplies to 64? I could have 1 times 64. I could have 2 times 37, or not 3, but 64 divided by 4. That doesn't work, or that works. 4 times 16, or not 5. It doesn't end in a 5 or a 0. Um, if I do 64 divided by 6, that doesn't give me a whole number. 7 isn't a factor, but 8 is. 8 times 8 is a factor. I don't need to go any further because I've used the same number twice. So now I want to check. 8 times 8 does make 64. Is 8 plus 8 16? Sure is. 8 plus 8 equals 16. So here's my two factors, x plus 8 and x plus 8. Um, that is the process. When a is 1, it's very quick. All we need to find are the two numbers that multiply to the last term and add to the middle term. So why don't you pause the video, go ahead and give two of the, or give number 3 a try and number 4 a try. So the end result for number 3, you've got 18 in the top, 11 in the bottom. What pair of numbers multiplies to 18 and adds to 11? Well, multiplying to 18 could either be 1 times 18, 2 times 9, 3 times 6, not 4 or 5. So there's my whole list of factors for 18. Which pair adds to 11? Well, that's 2 times 9. So 2 and 9 are my two factors. So then my are my two numbers that work for this trinomial. So then I end up with x plus 2 and x plus 9. For 4, you should have ended up with d plus 4 and d plus 2, because 4 times 2 multiplies to 8 and adds to 6. The bottom part of this involves some negative numbers. So give this a shot with 10, 11, and 12. So pause it, give those a try, and then I'll show you what those look like. So when I look at 10, I see A, B, and C. So my top number in my x is negative 56. My bottom number is negative 1. If I need two numbers that multiply to a negative, I need one of them to be negative. Then I make my factor pair list for 56, up to 7 times 8. I already used 8, so I know I don't need to go further. Then from there, I'm thinking about if one of these is negative, there's going to have to be subtracting those two numbers. So 7 minus 8 is the only one that could be 1, but since it's negative 1, it has to be, the 8 has to be negative. So 7 times negative 8 is negative 56. 7 plus negative 8 is negative 1. So there's my two factors. Oh, I shouldn't have used x. I should have used z. Sorry about that. For 11, negative 24 is the top of the x, 2 is the bottom. I made my factor pair list for 24. The only two numbers that could multiply to negative 24 and add to positive 2, multiplying to a negative means one of these factors has to be negative, so they're subtracting, not adding. 4 and 6 are 2 apart, and since this number is positive, the 6 had to be larger to add to 2. So there's my two factors. I just got into the habit of using x's. I apologize for that. I should have used h's for that one as well. And for 12, I should have used f's instead of x's. Old habits die hard, I guess. So here's my numbers for f. The only pair of numbers that could multiply to negative 40 and add to negative 3 are 5 and 8. So there's my factors. All right. Thank you.